Hi everyone. Here we are going to present on the and security audit and enhancement for a Go application, which is deployed on the cloud. Um, so these days, due to increase in cyber attacks and many other unauthenticated threats to applications on cloud and on premises, there is a high importance for security. So securing applications will help in preventing security breaches and also maintain trust for the users and also prevent loss for the companies. So here in the cloud host companies, there are many threats like code vulnerabilities and insecure containers and misconfigured cloud environments. So here we are going to secure the Go application in all layers using the best practices provided under. Next slide. So there are many security risks at different layers and at different levels. So primarily at code level, the security risks are there should be we should implement a robust input validation by using Ghost libraries at code level so that there is no threat to the code while using the libraries. And also, we shouldn't always use the hard-coded secrets in the code. Instead, use them or store them in the Azure Key Vault instead of directly writing them in the code. And also, we should always follow the protocols like industry standard protocols, which are such as OAuth 2 and many others. And also, the container security is also very important. We should always use lightweight and secure images, as mentioned, Golang Alpine, which is the base image with multi-stage build. And also, we should configure the containers to run as non-root users because when you run as a root user, there is a threat to the security of the container. And also, we should employ like scanning images, container images using tools like Trevi or to detect or scan vulnerabilities and thereby protect the containers. And cloud security, based on overall environment of the cloud, you should always use IAM configurations or IAM users by restricting the users to with the least privilege to access the cloud services. And also ensure that the encryption is done using TLS encryption for data in transit, and also employ server-side encryption for data which is in storage, and also use Azure Monitor and Security Center for real-time monitoring of the environment and also alerting. Thereby, we can be safe and be alert in protecting the environment of the cloud. And here we are also going to see the mitigation strategies, primarily for the Docker image vulnerabilities. We are You should secure the Docker and Docker images from the vulnerabilities by using the base images like Alpine. And also, we shouldn't always put the sensitive data in the images, like hard coding the secrets and passwords and any other data, which is very dangerous for the hackers. And also, you should keep scanning regularly the images by using third-party tools like Privia and Aqua for security. We should not, and we should run the containers as non-root users because running the root user and has all the sensitive data is a dangerous threat for the image and the application data. And also, we should adopt multi-stage builds to minimize the attack surface for the hackers or any unauthenticated users. We should practice secure coding for Go by using libraries like net and URL for net slash URL and validator for input validation, so that the libraries are secure while coding. And also error handling. Should avoid exposing detailed errors to users, and also use logging libraries like loggers so that we are not exposing anything easily to the hackers. And also the configurations are very important. We should manage secrets via environment variable or tools like HashiCorp Vault, which is very secure. And we should practice regular code reviews by ensuring that they are following the secure coding standards. And other best practices of cloud security are like IAM, which is the basic, the most important one. Like by IAM, we can restrict the users with least privileges so that whoever want to perform the particular task can be allowed to do only that task. Other than that, he is not allowed to explore any other services in the cloud. So that thereby we're restricting the chances of security breaches. And data encryption is also very important. We use TLS for data encryption in transit, and KMS for data at rest for key management service for storing the keys and decrypting them and storing them inside. And network security, like we are restricting by using security groups, we are restricting the access to the application which is in the cloud by providing only access to particular ports, whereby we are enabling this like SSH, RDP, or HTTP. And also use bastion servers for accessing the applications in the private subnet. Without directly accessing the private subnet, we can create a bastion server in public subnet and access that with the bastion host. And also monitoring, which is very important. Like for every action, for every event or anything undergoing in the environment, we should create uh, like tools like AWS CloudTrail or Azure Monitor for completely all 24/7 auditing and monitoring of the environment. And when it comes to CI/CD pipeline security, secret manager is very important to store the keys and passwords and everything in the pipelines, related to pipelines. And scanning, you should use third-party models like Snyk and Dependabot for scanning any vulnerabilities or any threats in the pipeline. And also build environments, which is very important. Harden, the build environment should be secured and isolated and secured, preventing for any unauthorized access. So the last one is access control, which is very important, so that you can you can enable the additional layer of security by using multi-factor authentication. So thereby limiting easy access to any user trying to access the the cloud services. So the next will be explained by you, my friends.
Next, coming to container security level and to core tools. First, coming to GoSec. Uh, GoSec is like identify vulnerabilities like injection attacks and hardcore credentials in Go code. It scans source files and provided detailed reports with security levels and locations. Then coming to SonarCube, like Go plugin analyzes the code quality and security, integrating with the CI/CD pipelines. It evaluates code for vulnerabilities and technical debt, offering user-friendly dashboards with fixed recommendations. Uh, Next, we coming to Docker vulnerabilities. Here, it detects vulnerabilities in Docker images, file systems, and Kubernetes configurations. It cross-references images with databases like NVD and provides scan results with severity levels and mitigation strategies. And next, coming to Aqua Security Microscanner, it focuses on scanning Docker images during the build process, specifically checking base image vulnerabilities. It integrates into Docker builds and provides logs with actionable fixes for each layer. Next, coming to cloud security tools. First is like Azure Security Center. It manages security across Azure environments, providing a secure scores, security recommendations, and threat protection alerts. Next, coming to AWS IAM Access Analyzer, reviews IAM policies to identify over permissive configurations and flags potential risks. And it also generating access reports with recommendation for secure policies. And this tool helps in ensuring both application code, infrastructure security through predictive scanning and automated vulnerability detections. These are the tools which will be helpful for the security. And next, coming to like analyzing the code, my friend is going to explain that. Thank you.
So we'll be using GoSec, which is a Golang security checker for our Go code to identify the potential security vulnerabilities such as SQL injections, hard-coded credentials, or unhandled errors. If you go through here, like you can see, like if there are after the GoSec execution, we didn't find any issues. So next we go through next slide, please. So this is like we are enabling application insights to monitor app services. This allows you to monitor application performance, usage, and availability in real time. It provides detailed data, including request rate, its response time, failures, and dependency tracking to help you to diagnose issues and improve your app performance. Next is like we are configuring the diagnostic sentence of our app service, which enables us to collect the detailed logs and metrics such as application logs, HTTP requests, and performance data. These logs can be sent to Azure Monitor Log Analytics to store the logs, helping you to troubleshoot and optimize the app. Next is like log stream. Is the log stream is very helpful for developers to provide application logs, enabling live monitoring output for app hosted in app services. So next is of Azure Log Analytics. So this helps us to store the logs, which is a centralized platform for collecting and storing and analyzing log data from various Azure resources, on-premise systems, and applications. It enables advanced querying, visualization, and monitoring of logs to ensure operational insights and troubleshooting. So here the challenges. So the main challenge is of managing hard-coded secrets. So storing secrets directly in code increases the risk of unauthorized access and exposure during version control. So the solution is to implement secret manager tools like Azure Key Vaults to securely store the access data. And the second challenge is of identifying container vulnerabilities. The container images with unpatched vulnerabilities can lead to security risks in production. So to prevent all this, we should use image scanning tools like Azure Container Registry, scanning to detect vulnerabilities and follow secure build practices. And the third challenge is of misconfigured cloud resources. So improper configuration in cloud resources can lead to security gaps and potential breaches. To overcome this, we have to review IAM roles and apply least privilege principles and enable continuous monitoring using Azure Security Center. Thank you.